Let's go signal. Then you go there.
All right, there we go.
I'm gonna try.
It's recording.
It's recording?
Yeah. I think this is working.
For sure.
All right.
Also, my data structures and I said rusty.
It's okay.
Yeah.
I'll stand back here.
Yeah.
Can I borrow that?
Take the
Can
time.
I borrow your iPad?
Yeah, sure.
I like just having this solution up. So
Yeah.
fun up. We can do the same. How's this? Oh, interesting.
I'm gonna to do the speech.
Okay. All right, guys. Good afternoon, everyone. Real quick, quick introduction. My name is Azam Renee. I'm part of the National Society of Black Engineers. I am our academic excellence technical chair, so I deal with like workshops and whatnot. So I collabed with Knight Hacks to kind of put this event together for you guys. And then today we have Tomiwa here.
How you doing? My name is Tommy Oluko. I'm a computer engineering student, so unfortunately, I did not have to go through the stress as you guys went through. But I'm still, well versed within my data structure and algorithms. I usually work with Python, so it's going to be a bit of a let's say a refresher of me trying to roll back to C. So yeah.
Yes, sir. And then we got Adam here.
Hello, a lot of you know me. I'm a TA for CS1. Happy to be here and do this workshop. Or at least have the workshop anyway. Thank you for inviting me to be here.
For sure. Thank you guys for coming. So we got access NSBE and yeah, let's get to it.
Thank you guys for waiting, by the way. Sorry for the wait.
Why are there like two slides of the same thing?
Okay, we're keeping them both. Did everybody do the QR codes for NSBE?
Yeah, anybody else need that?
You guys got that? Wait, is it up on the tip?
Take care, man. I'll see you around.
Thank you so much for everything.
Of course.
Making you.
No, you're good.
I didn't know that the shit in here.
It's fine.
Thank you, though.
Of course, man.
Yeah.
Do you want me to just do the overview too? Should I just do the overview too of like the whole thing?
We can swing back and forth.
Okay. Do you want a chair?
You don't have to stress about that.
Okay. All right. Anyone else need this? Okay. Raise your hand if you don't know anything about the foundation exam or how it works. Okay, raise your hand if you didn't know you'd have to register for the foundation exam. Do me a favor. When this workshop ends, go register for the foundation exam. I think it should be open. If it's not, then hopefully soon.
Yeah. Wait, first of all, raise up hands if you, do you guys ask this question if you don't know what the foundation exam is?
Sort of.
Yeah, okay. Well, did anyone need an explanation on what the foundation exam is, the FE exam? All right, so,
Is anyone here who doesn't have to take the FE and is just here for fun? Okay.
okay, I get that.
Just
Yeah.
here for midterm prep?
I guess who's here to refresh on data structures for interviews?
Who's here for the CS1 midterm?
Okay, see, that's even better. I didn't know midterm season. Like,
Yeah,
I did
Saturday.
all my advances last week, so yeah.
That's right. Say what?
How do you?
There's a link. Just search like foundation exam registration. That's there. Say that again. It's on Google. You just search it. It should come right up. So the foundation exam has 4 structures, as most of you know. Each structure has there's 12 questions total, 3 questions per section, 4 sections, so that's 12. Each section has 2 harder questions that are worth 10 points and 1 easier question that's worth 5 points. So of course, if you can, do the harder questions, but if you can't, try to do the easier questions. Of course, I know, same thing with the midterm too. I mean, obviously the midterm doesn't have all these separate structures and whatnot, but never leave a question blank because you never know what partial credit you get. I just graded a quiz this morning. Someone literally wrote 2 lines and it was worth 10 points on the question. So you never know. Always put something. Something's better than nothing, even if you think it's completely wrong. Any questions on this? All right, cool. So there you go.
Yeah.
So yeah, basically this workshop, we're not going to be covering all the data structures, but just the main important ones within C, especially for your midterm exam. So we're going to be coming over DMA, linked lists, and queues.
Is it just me or does this have like a little thing in the back? Or am I going crazy?
Nah, we also see it too.
Okay, I just want to make sure I wasn't going crazy. All right, everyone's favorite. Okay, who's the most afraid of DMA?
I'll be afraid to say it. Ever since I went to
Don't be nervous.
Yeah.
All right, so we're gonna do 2 questions on DMA, but of course, a quick refresher. You know, to dynamically allocate memory, the whole point is so you can, when the program runs, you don't have to deal with variable length arrays, things like that. Basically, in C, you have to basically remember you're in control of the memory. And you can first make dynamically initialized variables by using malloc, the usual, which looks like this. It makes anything you call with, it initializes it to garbage. Calloc does basically the same thing, except it'll initialize everything to 0. And then realloc is if you do one of these two and you need more space, realloc will basically grow that space for you without having to do everything by hand. It'll basically take care of all the freeing and whatnot for you. It'd be cool if there was a thing to do that with freeing itself, but there isn't. Any questions on this? I hope this looks familiar to most people. Well, what I meant by that is when it makes the array bigger, it will take care of freeing the old one and transferring everything for you. You still have to free at the end, but in between you don't have to free. Yeah, it could be there. The Ahmed's quiz just had a realloc thing on it, so it's important to know how it works. Any questions? Anything else? All right. Of course, freeing memory. Always work from the inside out. Get as far in as you can. That's whatever's dynamically allocated, and then work your way back up. Otherwise, you'll free pointers and have a memory leak. And to free something, so hopefully this is pretty self-explanatory. If you dynamically allocate something like this pointer, and then you want to free that pointer, you literally just pass in the name of the pointer to this free function, and it'll free it for you. And then if you try to use something after you free it, well, that's not going to work. That's basically called a that's one way to get a double free error. The other way, actually, no, this is probably do a seg fault. My apologies. A double free is basically you free something once, then you try to free it again. Well, then that's going to cause a double free error and would crash the program. Questions? I hope this isn't new to anybody. Okay, good. Just checking. Common mistakes, you know, what I always say is a good rule of thumb, you know, if you're initializing a double pointer, for example, that's dynamically allocated over here, whatever is on the right side, wherever you're calling malloc, what goes inside, this is actually, now that I'm looking at it, this is actually an error, and I remember this now. This star should not be here. This should be one step down. And what I mean by one step down is, see how I have 2 stars here? This should be one step down. Same thing, if this was a single, then this would have no stars. Always go one step down. That's a great way to know if you're doing that right. Just, you know, self-checks are always helpful, I feel like, on these kinds of questions. What else? Oh, these were errors. I'm stupid. I thought this wasn't an error. So yeah, again, go one level down, otherwise you're going to cast the same thing, that won't work. And remember, you don't have to have this explicit cast there. You can, but I don't think it's necessary, especially since it'll implicitly cast it to whatever's on the left side anyway. Make sure if you dynamically allocate something, you initialize it too. Like, for example, this string, you declared it, but you didn't initialize it. So you're basically trying to assign something to a garbage address. That wouldn't work. Make sure also when you're using DMA, whatever is dynamically allocated, you're doing it with a pointer. Otherwise, that's not going to work either. And same thing with, you know, just make sure everything's basically allocated if necessary and initialized. So any questions on that? Hopefully, I know this is probably too quick of an explanation, but hopefully you cover that more in lecture. So, you know, some good tips. Make sure when every alloc, so malloc, calloc, realloc, whatever, every one of those calls has a corresponding free, otherwise you'll have a memory leak. Who doesn't know what a memory leak is? A memory leak is basically you don't free dynamically allocated memory or you lose control to it. Basically, as an easy example, say I have a variable, a pointer X and a pointer Y that are pointing to 2 dynamically allocated boxes. If I then say have X point to whatever Y is pointing to, see how you lose control to this? and you can't control it anymore. So then that memory is just gone and trying to run forever. And that's what's called a memory leak. You don't want to do that because it'll slow down your code, not even your code, your whole computer, honestly. And it could, if you have too much of it, just crash your computer entirely. So don't do that. Also because you'll lose points. That's also another good reason. Any other questions with that? So just remember, every alloc should have a free, like I said, go one step down. 2D arrays, you got to be careful because, sometimes you can use the array syntax. Sometimes you can't use the array syntax. It just matters on the situation. More often than not, though, you can. Don't forget also when you're dynamically allocating a string to always include one more space for the string terminator. You got to remember that string terminator. If you don't have that, it's not a string technically. And when you try to print it or string copy or whatever, it won't work properly. Does that make sense?
2D and 3D.
3D array isn't really covered.
Oh,
What do you mean by 3D array? Okay, but you can explain that.
no, it's not relevant. So
Okay. I basically said everything else here. Sorry about that. Yeah, the only thing I just make sure when you're allocating something in a function, which there's not, I thought there was an example. Just make sure you're returning the type of variable that's based on the return type of the function. Otherwise, that's not going to work properly either. Any questions on this quick overview? Sorry, I always get nervous in front of a public audience like this, so I always mess up my words. I apologize for that. Any questions? All right, cool. I don't think you really need to know this for the midterm. But an integer is 4 bytes, a character is 1 byte, a float is 8 bytes. That's really all you need to do to know. I haven't really seen like this. This is the foundation exam I took. It didn't really ask you how many bytes it was. It asked you basically like just draw the stack in the heap space. The heap space is where the DMA is. The stack space is where the static memory is. But this really isn't as important, but it's still good to know just in the back of your head. Really just know how many bytes each type of data type is. I've never really seen a question about like how many bytes is a pointer. But I guess here it is if you want to know. 4 bytes for 32-bit, 8 bytes for 64-bit. Any questions on this? All right, I think, nope. When do we get to, okay, there's the questions after this slide. We really talked about this already. Again, see here, this is a good example. So look at the return type. You should in this function be returning a double integer pointer, which you are, the IPP. It's the same type, so that's good. And then see, we're dynamically allocating an array of pointers with IPP and see how it's one step down from this. So that's also a good sign. Make sure you're doing that. And then once you actually go into the pointers using the array syntax in this example, see how dim2, remember, this is technically a pointer, a single pointer, and this is one step down again. I cannot emphasize that enough. Does that make sense? So really, it's just go over, you might have to use loops, of course, to do the stuff with like arrays, but aside from that, there's really nothing else I can think of. Any questions, comments, concerns before we actually do some problems? All right, so let's actually do some problems. I think this will be better once we get into some problems. So there's 2 from the most recent foundation exam.
Actually, do you need a second monitor or?
Yes, please.
Okay.
I just need to see the solutions in there.
Yeah, I think it's well. Appreciate it.
All right, sorry. Let's do this. All right, cool. 5-point question. This one's an easy question. DMA is almost on every foundation exam of some kind. Consider the following code that attempts to allocate a new array with the same number of rows as ARR, which is a pointer, an array of pointers basically, but triple the columns. Copy the values from, then it'll copy the values from the original array into the new array in the same slots, free the dynamically allocated memory pointed to by the original array, and then return a pointer to the new array. So basically you're just copying everything from this original array, but making sure this new array you're making has triple the amount of columns. Does that make sense? Always, 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 when you're doing any kind of these questions, don't jump straight into coding or anything. Make sure you, I know it sounds stupid, but think about what is the question asking you? Seriously. Because if you don't know what the question's asking, I've seen so many people be like, oh yeah, I'm just making this up. It wants me to make an array. Cool. And they just make a random array that's not even anywhere close to the question. You have to make sure you understand what the question's asking you. Take the time if you need to. Once you understand, then don't just jump straight in. Like this one's kind of easy, but if you're asked to write a function, I cannot emphasize enough also drawing out examples, sometimes making literally like a step-by-step checklist. That saved me in one of my foundation exam. It's really helpful. These things might sound stupid, but they're really good for these questions. But anyway, let's look at this. So basically, we already have the code here, as you can probably already see. And there's 2 points. There's 2 errors in the code. So we basically have to answer questions on that. The first question is, what is the fix for the line of code at point A? So we can just describe the fix here. I don't even need to write out the code. Does anyone have any idea here? What could be wrong with this line here? Say that again. Why do you say it shouldn't be times 3? Exactly. Because looking at the question, it should have the same amount of rows, but it should have triple the columns. So basically, this *3 should go away. Does that make sense to everybody? Everyone understand that? Any questions with it? Okay. So really, I'm just going to say remove the *3, since the number of rows needs to be the same. Then the second question is, why is the line of code for point B incorrect conceptually? Any ideas? Sure. Why is this line wrong conceptually? No, array is being passed into this function. I should have mentioned that. That's the original array. ARR is the original array we're trying to copy. This one kind of gets to pointer syntax a little. Yeah. You're on the right track.
Are you supposed to dereference the array?
You don't want to dereference the array. If you think about it, this ARR at R, that's technically a pointer. When you use the array syntax like that, that's technically a pointer. So you're basically saying here, hey, set this equal to a pointer. Set a pointer equal to a pointer. But then the problem is, remember, we're trying to set this to a normal integer value. So the problem is, once you do this, and then you free that, you're not going to have that anymore. You need to actually copy over the value inside ARR at R. Because this here is a, this new array at, how do I say this? New ARR in each row, those are just integers. So, but this is a pointer here, I believe, because this, honestly, the solution's kind of vague. That's a goof for you. But basically, it just reassigns the pointer to point to a different location instead of copying over the values. Does that make sense? It basically says this line, because right here, this is a pointer. It's like I said, it's copying over the pointers and not the actual integer values. That's the problem.
So what the right code looks like?
I believe the right code, you'd want to actually store it into a normal integer first. So squeezed in here, you would say int, I'm just going to call it x equals ARR at R. And then instead of this, you would just say that equals x. I think.
So you can't just dereference it?
I feel like you can. That's why I'm like struggling on this. I'm being honest with you. It literally just says the line of code reassigns a pointer near R to point to a different location instead of copying over the values. It honestly doesn't feel like there's anything wrong with this. I'm being honest. Does this make sense, I guess? I know it's probably a little shaky. So I'm just looking at this. No, yeah, that's a row. Oh, you know what? I just realized what's wrong. Okay, think about it here. This is why drawing is helpful. Let me draw a quick visual. Let's say, I'm just gonna make this up. Let's just, I know this isn't to scale, but let's say this is the array here. This isn't to scale. So this is new array. This is 0, 0, 1, 2. So then all of these, this is new array at 0, and this would be the same thing at 1, 2, etc. Does that make sense? So as an example, let's say we're at 0 here. So new array at 0, if you think about it, this is here at the start, and this is dynamically pointing to all the current row up here. Let me do a different color. This is dynamically pointing to this row. This pointer is pointing to that row. Does that make sense? The problem is this is then saying, okay, hey, instead of pointing to that, point to what's in the original one. You lose control to it. It's a memory leak. That's the problem. Does that make sense? Does that make more sense?
For this one, would you need to make another for loop to iterate through the columns?
Exactly. That's also something you would need to do to copy everything over.
And then it would be like, the line would be like, new RC equals RRC, right?
Exactly.
Okay.
Yes, that's what the problem is here. You can't copy a whole row like that. Does that make sense, everybody? I apologize for that confusion there. Oh, great. Guess what? That's what Brandon just said. Let's do it. So basically, instead of this, let's actually transfer the values over. Because again, we don't want to you don't want to try to copy whole row, we got to copy each individual value. So to do that, if we're already looping through the rows, what do you need to do? You got to loop through the original columns in the original array. Doesn't that make sense? Say that again? Yeah, another for loop, exactly. So what you can, yeah, it's going to be a nested for loop, but it's asking for the two line. It's basically asking, instead of like basically what would go in this place. So we don't want to actually write all of this again. We're going to write what would go into here. Does that make sense? So we would just loop through. So it'd be for int I equals 0. I is less than, now think about it. What would I be less than?
Columns.
Yeah, I guess it would be columns. Yeah. Because the last 3 columns should be empty. So we I is less than calls. I plus plus. Or I'm sorry, no, I is fine, whatever. So then we could just say new, you know what? Let me change this to C so it's less confusing. I think C would be better. Then you just say, well, new array at now RC equals the original array at RC. So then this whole thing combined should be going in where point B is. Does that make sense? So that's this question. That's it. I apologize for the confusion with part B. It's just when you do this for so long, you're so used to having to really think about stuff. And I'm so notorious for overcomplicating stuff. So I apologize for that. Any questions on this before we move on? Need a minute to ponder over this? Anybody?
Yes.
I already guessed, so I'll wait.
And it should only win 5 points.
Yeah, this is only worth 5 points. I told you, 2 of them are easy, 2 of them are hard, 1 of them's easy. A lot of the conceptual ones are the easy ones. We're about to get to a 10-point question. All right, so I'm gonna keep moving just so we got time here. So here's the other question. This is a 10-point question. So this is gonna be what a harder question's like. All right, you ready for this? This is a coding question. This is a good one. All right, consider the following type def struct definition that represents a basic bank checking account. Struct representing basic checking accounts. So here's the structure, which I almost can guarantee you is probably written by Ahmed since he's notorious for doing _T next to structure names for some reason. Anyway, in the structure, we have a name, which is a pointer. So if you see a pointer in a structure, what does that typically tell you? Say that again? Yeah, this is probably most likely going to be dynamically allocated. The name will be dynamically allocated, but then you just also have an amount for the account and an ID for the account. Makes sense, basically. You have the person's name in the account, the ID of the account, and how much money is in the account. Makes sense so far? Now, basically, complete the following user-defined function, merge accounts. The function will combine two accounts that were already declared with the proper information into one account. Please note that they're already dynamically allocated. You will need to properly allocate a new struct in the key space that will store the combined info. This means the following is going to happen. Number one, the names with both of the accounts that are being passed in here that are already initialized and whatnot will be merged together. They will be separated with the word and. So for example, if the first account's name is Sonic and the second account's name is Amy, the new account name would be Sonic space and space Amy. You have to make sure there's enough space to accommodate for that in this pointer up here. Does that make sense? Second thing, the amounts of both accounts will be summed together. That makes a lot of sense. Why would you merge two accounts and then not combine their money? That makes zero sense. The third thing, the ID of the merged account will be the original ID of account 2, not number 1. The last thing is no changes should be made to either the original accounts. So I guess it's almost like these two people got married and they're having a joint checking account, but then you're leaving their old accounts alone.
It'll be in their life.
So, any questions on what the question's asking? Make sense, sort of? Okay, so now let's just go through this step by step. So, the first thing, remember, we got to return a dynamically, even if this didn't say DMA, it's a pointer. So that should be ringing a bell in your head. The return type's a pointer. It should be ringing a bell in your head. This is going to be some kind of dynamically allocated structure. So if we're going to dynamically allocate something, who do we got to call? Malloc, exactly. So to do this, we could say account T, and that's going to be a pointer. Now, what are we dynamically allocating up here? Exactly. We're making the actual joint account. So I'll just call this new. You call it whatever the heck you want. And then I'm going to call malloc to dynamically allocate it. And then what's the parameter of malloc going to be? Size of what? Is it account T or is it struct account T? Good. Just checking. Just checking. It'd be account T. Okay, cool. So now we have up here, here's new, and this is an account. Well, actually, that's actually a pointer, excuse me. And that's pointing to the new account up here, which will have all the 3 values and whatnot. Does that make sense so far? What we've done? Okay. Now let's actually go through step by step what this is asking us to do. The first thing we should do is merge the names together. Now we have to be careful of this. When we make a string, what's the most important thing with the string when you dynamically allocate a string? Well, other than the terminal, what do you need to the length? You have to know how many characters you're allocating. So let's take this slowly. Don't you think it'd make more sense? Let me ask you this. Would it make more sense to put a giant expression into string length or make a variable? Let's make a variable. I mean, you don't have to, but I think it'd be a lot easier on you and the grader to make a variable with the length. So let's do this. We're going to call it int. I probably should give myself more space. Hold on. Oh, whatever. I plus the semicolon. There we go. So we're going to make int. I'll call it name len. This is going to represent the length of the new name in the account. So let's be careful here. What do we have to add in? We need to add the original account name or account number 1's name and account number 2's name. So how would I get the length of account number 1's name? Right. So first, what do I call to get the length of a string? String length. Now, based on this structure definition, and this is account 1, how would I access the name in this account 1? Exactly. He would say account 1 arrow name. Okay, cool. So now if that's Sonic, for example, we know that it's going to be 5. Okay. Now, how do we get the string length, or how do we access the second account's name? I kind of just gave it away. Exactly. Now, would we add, multiply? Add. Just making sure. String length of account 2's name. Okay, cool. Now, was that it?
+6.
Okay, you said 6. What, I just want to get a consensus here. What do you think we need to add in?
3 letters and 2 spaces. No, 3 letters, 2 spaces, that's it.
You have to add the terminator, exactly. We need, if you think about, because we're merging in and, if you look at this example, we're gonna basically have 6 extra characters we need to allocate space for. Here's 1, 3 for and, another 1 for another space, so that's 5, and then you have to get 1 more for the terminator at the end, so it'd be 6. Does that make sense to everybody? This is why it's really helpful to work with examples here. So then we'd also add in +6. Okay, cool. Now we have the actual length of the string. I'll try to squeeze this in over here. What the heck? Okay, +6. Great, whatever. Just know that's there. I was just trying to get on one line. Yeah, yeah, I guess I could do that too. Good point. What the heck? There, that better? All right, so does this make sense so far? Okay, so now we've made the space for the name. Now we actually have to get the names in there. So we gotta be careful here. What's gonna go first in the name of the new account? Account 1's name. So how can I get that in there? Yes, you have to remember when you're copying a string, you can't just do an equal sign. You have to call string copy. So we can do string copy. Now is the destination or the source first?
I mean, destination.
Destination. So if we want to go to the new account's name, how would I access that? New arrow name, exactly. New. Oh, you know what? I didn't make memory. I'm skipping a step. I just did one of the mistakes. We have to allocate memory for this. Duh. So how would I allocate memory for the name? Exactly. Malik times name len times size of char. I don't think you have to put the size of char because it's 1 byte, but do it anyway. Now, what am I going to put over here? Because we're allocating memory for the account's name. New arrow name, exactly. Now we have the space for the names to be put in. Does that make sense? I apologize for skipping that step. Okay, now let's actually get the names in there. So as we said, we can string copy the destination, so new name. And then we're going to get the first account's name. So it would be account 1 arrow name. Does that make sense? Okay, now how do you think I can get the and then the second account's name? Can you call string copy again? Can you call string copy again? Why not? Right, it would basically overwrite what's already there. So as a couple of people said, you have to call, I honestly didn't even, I guess I should have thought of this, but I really haven't used it, so that's why I didn't know. In C, there's a function in the string.h library called strcat, string concatenate.
On the reference sheet. So
Oh, they do? Great.
yeah, if you didn't look at it, then you were like screwed.
Yeah, that's true. So basically, concatenation means if you have a string with X and then you call string concatenate X and then you add in, let's say, AY. I don't know why I just came up with that. Then that would basically stick AY onto the end of the string. Does that make sense? So that's what we basically have to do here. So what am I going to concatenate onto the name first? Space and space, exactly, because that's what the question said. I just did string copy, force of habit, sorry. So on to new name is going to be quote, you have to put in quotes because it's a string. There's a space here. So I'm doing a space and then there's another space here. Just know that. Okay, now we have the and. Now, how do I put on the second person's name? Well, a string concatenate, new name again, but this time it'll be account 2 name. Does that make sense? Okay, so after doing all of that, we've done this finally. Does that make sense? Now we have to basically update the amount to reflect both the original accounts. So how can I do that?
If you access it, so new arrow of your equals.
New arrow amount, good. This would be new. Is it AMT? No, it's actually amount. New amount, the new account's amount is going to equal what? Well, what'd the question say? The original two summed together. Exactly. Account one, arrow amount. I'm going to run out of space again. Oh, no, I'm not. Plus account two, arrow amount. And that's that. That's the easy one. Does that make sense? Now, lastly, we just have to put the ID of the original second account. So how can I do that? Exactly. You just say, okay, hey, I want the new ID to be equal to, it's just literally one line. Account two's ID based on the question. Cool, done. Now, what's left? Anything? You have to return it. Good. Because remember, at the end of the day, you got to return an account T pointer. So we just return the new. Exactly. And that's it. Does that make sense to everybody? Any confusion or questions or comments? Yeah. You don't need to free the memory because we're making a new structure. This is basically be like, hey, I'm going to call this function to make a bunch of new joint checking accounts. We're not free because right here it says no changes should be made. So we don't need to free anything yet. It might ask you to free it later, but right now you don't have to free anything. Does that make sense? Yeah. Well, normally, okay, this is not usually condensed. Imagine this is like half a page, probably. Each question takes up a page. Well, let me say that most questions. There was one question where this whole part took up a page, and then you have a whole page to write the code because it was long. But generally, it's like this will take half, and then this is the other half. It's plenty of space. And any other questions? Makes sense? I hope. Okay, cool. So there it is. Any questions on linked lists? Or why did I say linked? DMA. Any questions on DMA? All right, so we're gonna move on. I think linked list is next.
Yeah, like this, I'll just explain and you could do the examples. And if there's anything that you see wrong, you can just interject.
Okay, sure.
So I'm just trying to.
So who's doing the overview?
Hmm?
You're doing the overview, right?
Yeah.
Okay, here. Well, I'm gonna. What's your name?
Oh, Tommy.
Sorry, terrible names.
Something.
Adam.
You know what?
Yeah, just use my laptop. It's fine because you got to scroll through it.
I have my talking notes already.
Oh, you're good.
It's green.
Just tell me when you need to go to a new slide.
Yeah, wait, question.
Yeah.
How many points was the string heads? Line?
1 point per line.
One per line?
Yeah,
One month, so it's.
2 points for total for the shrink hats. One for each. I don't know how they come up with the grading, but they just do. Anyway.
All right, guys, so for the most part, who knows what a linked list is? All right, so I guess we passed that stage. We're on midterm stage, we're around like what, stacks or what do you?
Algorithm analysis.
Yeah, okay, algorithm analysis, okay, for sure. All right, so linked list is a very popular data structure used not only within your class base, but also used within a lot of style interviews, especially just critical thinking on how things work. So what is a linked list? So a linked list is contains of three things you already know: of the data, the X pointer, and the previous pointer. So why linked lists? One of the biggest issues with both static and allocated arrays is that it needs to be contiguous. So basically for the linked list, it has a O of N search time, right?
Yeah,
Yeah. O of N search
it's
time.
linear.
So it's the second fastest search time when needed to run through your code for everything. So yeah. And another thing, for the next pointers, Each element called a node, holds the data at a pointer for the next node. So you guys already know that. And, you could skip up to the next slide. So we already know the type of linked list. They have a singly linked list, a doubly linked list, and a circularly linked list. Main thing that we work with are singly and doubly linked lists. So that's when, yeah, that shows it right here. So singly linked list is when it, points directly through the list. And doubly linked list when you come back to previous and next nodes. And that's really just how you format your code on how you traverse your list. Does anyone have any questions about linked lists or anything like that? Okay. And then for the, are we doing traversal slide? Yeah, for the traversal slide, how you code this up, so here's a code snippet. So basically, first thing you're gonna do is you're gonna grab the head node. So you need to initialize that by, with your pointer and node head. And then the second thing you need to do is create a while loop. So, you always need to have the base case condition of, pointing loop to null. So, yeah.
Well, not if you're going if you're in a doubly linked list and you're going backwards, then you wouldn't want to have it.
Yeah, for the singly list, I'm gonna say. And then from the operation, and that's how you increment it by hour setting you want. And then here's the type of linked list problem that you want to.
Yeah, sure, if you want. So basically, like any topic, there's two problem types you could, either it's like conceptual or a tracing or coding, basically. So mostly the linked list, it's just either traverse the linked list, trace through a function that has a linked list in it, see what it outputs, or actually code a linked list. So I basically just said the same thing twice now that I'm thinking about it.
Yeah, basically my visualization is thinking outside of the scope. Is that I see a singly linked list as like just a one-way street, and then a doubly linked list like a two-way street, or imagine like a straw where you could come from both ends. And then where you use a circularly linked list, think of it like at the racetrack where both ends connect. So those are like some type of visualization you need to make with making those critical thinking moments with the exam. So yeah, so very common mistakes is that you always never forget to null pointer check. So that condition is very important in order for your list to work. You always have to make sure that you free the current node before the traversal starts. So I think that's pretty much the standard. You guys already know what that is. Don't make that mistake. So yeah.
Wait, what do you mean by free the current node before traverse?
So you know how you were talking about malloc and everything. So basically, sorry, it's been so long.
You're good.
Yeah.
If you're doing this iteratively, free the node before you traverse. If you're doing this recursively, you got to get to the end and then work your way back up. Sorry.
No, that was good.
Any questions? All right, should we do a problem? Is this you, me? Okay. Okay, this one's fun.
Do everything. I totally forgot all this.
It's okay. AJ just didn't want me to.
Oh, yeah.
All right. Ready? We can store an integer in a linked list of nodes where each node stores a digit in reverse order. For example, the integer 2163 would be stored in the linked list as 3 pointing to 6, pointing to 1, pointing to 2. It's reversed. Using the node structure shown below that is used to store numbers within this manner, write a recursive, I repeat, recursive compare to function that takes in pointers to two integers stored in this manner and returns a negative integer if the number in the list pointed to by num1 is less than the number in the list pointed to by num2, or 0 if they're equal, or a positive integer. Wait, what? Why is it saying that again? Oh, I'm sorry. Or so negative if num1 is smaller than num2, 0 if they're the same, or positive if num1 is greater than num2. Does that make sense? For example, compared to with the length was 3612 and 4612 should return a negative number since the left is smaller than the right. And compared to with 3612 and 9991 should return a positive number since num1 is larger than num2. Does that make sense? Which is weird because yes, it is. I forgot this in reverse order. Remember, this is in reverse order, so it's kind of trippy.
A negative number is in the product, or negative numbers is just -1?
Just a negative number as any negative one's a good one. It's just like a flag, basically. Just return -1, just to like a negative number. So like, okay, hey, this one's smaller. Just an indicator variable. Yeah, basically.
They're supposed to return the difference, which is gonna be. It's gonna be the same thing though, right?
What do you mean the same thing?
Is it gonna be less than 0? Like if you turn the negative like product, the negative sum.
Well, we're not getting a sum here.
I'm saying like if you subtract, if you subtract 2 or 1 from 2, and you get, that's a bad example, but like, if you subtract like 9 from 6 and you get -3, it's gonna check if it's less than 0, right? So it's gonna be like a negative is a negative is a negative.
No, that's not what this is saying. It's basically saying just determine which number, if number 1 or number 2 is bigger and smaller. Like which one's bigger, which one's smaller. If number 2 is the bigger number, return -1.
Or at the very end.
Yeah, at the very end.
Gotcha.
Because the whole point of this function is you're comparing two numbers and saying which one's bigger.
Yeah.
And that the -1, you're either gonna, you literally says return either basically 1, 0 or -1.
I thought it was comparing each node.
Well, you're kind of gonna have to implement it that way, yes. But really, you're just going number by number, if that makes sense.
Gotcha. All right.
Any other questions? All right, so how do you think we could do this? Since we do this recursively?
You're gonna go all the way back, and then you're gonna go all the way back again, comparing by the highest value. So you start by the thousands place and then the hundreds. And the tens and ones.
You could do that.
Why, when it comes to the recursive problem, what is like the first thing you should think of doing?
No.
Yeah, the base case.
Yeah, so if it hits null, you stop.
If what hits null?
If you can assign a temporary point.
Num1 or num2 or, like, well, how do we know? Well, think about it. There's three cases. Either you're comparing two numbers and they're either equal or one's bigger or one's smaller. So let's take care of the case that they're equal. How would I know if the two numbers are equal? Well, yeah, but well, just hold on. Before we even like do that, just think about conceptually. How could I literally recursively check if one number's bigger? It's kind of what you said. Yeah, that's basically how we're gonna have to do this. We're gonna work our way to the end and then take the difference each time. And at any point, as we work our way back, we're gonna basically say, okay, are they the same? Are they the same? If they're not the same, whichever one's, if one of these is different, you know, like we get back to here, 4 is bigger than 3, so we'd automatically know that this one is bigger. Does that make sense?
Will we not do like a base case for us to see if one has more nodes and that one's automatically bigger?
Well, the problem is you can't just check if one has more nodes without traversing through the whole list anyway. Some questions might give you a function that does that, but this one's not giving you that. So let's just take care of the base cases first. What if the two numbers are equal? How would I check that? How would I determine if the two numbers I'm at are equal? The two digits? Exactly. Whoops. If num1 well, no, we have to be careful of one other thing. What if we don't know if what if these numbers aren't even, they're past 10? What if they're not initialized to anything? Yeah, you have to have a null check too. You got to make sure you check null. Because otherwise, what if these are both garbage? Well, then you can't check anything else. You crash your code. So you have to have the null check. So if num1 is equal to null, and I cannot draw an ampersand for my life, and num2 is equal to null, if either of those are equal to null, what would I return? 0, because technically null is equal to null. Does that make sense?
Wait,
Sorry.
never forget to check. Oh, yeah.
Okay, so then really, now let's just be careful here. How could I now, let's say num1 is equal to null. What if like, because there's really 3 cases if you think about it. They're both null, one of them's null, or they're both not null. And if they're both not null, then we're actually going to traverse through them. But what if only one of them is null? We have to take care of this separately, right? Does that make sense? So what if num1 is equal to null? What would I return then?
Yes, sir.
Exactly, you return a -1. So if num1, only num1 is equal to null, well, return a negative number. So for us, we can just return -1. Otherwise, then what's the other case? What if num2 is equal to null? Well, it's the same thing. If num2 is equal to null, now this time we'd return 1 just to signify, okay, num2 is bigger since num1 doesn't, or num1's bigger since num2 doesn't exist. Does that make sense? I hope. All right. Any other questions so far? Okay, so now we actually have to be careful of, okay, both numbers exist. So then now let's actually try and check them out, see if they're the same. Or whichever one's bigger. So if we want to do that, basically what we can do, get all the way, as we said, get to the end, and then as we work our way back, just return the difference between them. Because as we're returning the difference between them, if one of them's bigger, if one of the digits is a mismatch, you can immediately know if it's bigger or smaller. Does that make sense? So how would I traverse through this recursively? Well, we don't want to return yet. Let me make it. You don't need condition. Well, first, just tell me, how would I make the recursive call? Compare to num1, 2, num1 next, num2 next. Exactly. Okay, but then remember, as we're traversing through, eventually this is going to hit a base case. We're going to be working our way back. So we have to see if we're working our way back, is it equal or not? Because if it's not equal, then we can immediately know, okay, just return basically whatever this did. Does that make sense? Sort of. Well, we don't want to just jump straight to the difference, because if it's not equal, if the digits aren't the same, then we don't want to return the difference. We want to return the difference. How do I say this? Basically, normally, yes, we're going to return the difference between them. But if this is not equal to 0, we just basically want to return what happened further onwards, because that was the difference between them. Does that make sense?
I think you just got code out that way.
Okay, yeah, let me just do that. So basically what you have to do is say int temp is equal to this. Then you would say temp, or I'm sorry, if temp is not equal to 0, we'll then just return temp. Otherwise, just return num1 digit minus num2 digit. So basically, what this is doing, this is going all the way to the end of the list. So basically the biggest, the 1000th place in this example. This will go to 2 here, and this 1. Then as it's working, it'll then hit the base case here. Then as it's going back, it'll basically check, okay, hey, are they equal? If they're not, well, then just return whatever the base case was, because that'll tell you right away if one of them's bigger, one of them's smaller. It'll tell you the difference. Otherwise, you do want to return the difference between them so you can keep working your way backwards and each time seeing if there is a mismatch. And when there is, return the proper value. Does that make sense? Sort of.
What is that if 10 not equal to 0?
So let me do this as an example. So if we're comparing 3, 6, 1, 2 to 9, 9, 9, 1. So basically what this is doing, this is num1, this is num2. We're going all the way to the end, right? So then we're here. And then it's going to go one more. So go out here. Are both numbers null in this example? Yes. So this is going to return 0. Then we go back. Now we're here. Temp was equal to 0 because it went out one more to the right. So then it would return the difference between them, which is 1. So now we have 1 in our hat or our hand. And this goes back with a 1 on top of it, basically. Then it does the same thing. Basically, it's going to, if it's not equal to 0, now it's going to return 1 and 1 and 1 and 1. Nothing would change because we already could tell right away, okay, num1 is bigger than num2 at the first digit.
Can you run that back real quick after you got to the end? So you should first always end the list.
So let me do that one more time. So we begin by, none of these base cases are true, so we do this a bunch of times. Then once we're at the end of the list, it's still going, so it's going to go one more because the base cases aren't true. Now we're out here. Num1 is null and num2 is null, right? So then this would return 0. So then as we work our way back, since there's no more recursive calls, we go here. This would return 0, or that we have a 0 in our hand. But then looking at this, temp was not equal to 0. What am I trying to say? This is equal to 0, this base case, or this if statement. So we're going to do this. Return the difference between them. Because basically now we're saying, okay, we're at the biggest digit. Return the difference between them. Because hopefully if they're not the same, we can immediately determine which one's bigger. So this would return 1. And then since this would be 1 a bunch of times, this if statement, it would just return 1 all the way back and you know which one's bigger. Does that make sense? And it's a positive number, so it's fine. Now, if you had, let's say, a 3 out here, instead, it would go all the way out here. This would be 0 because both of them were null. But then as it went back, since num1 is null, it would return -1 because num2 is bigger. Does that make sense how this works, sort of? Well, no, it's returning a bunch of times. As it traverses back, it's doing a return each time. It's just the value isn't changing.
When it hits a -1 or a 1, like it'll be done. Yes.
Well, it still has to recursively go back to the top, the beginning. It just, the return value itself isn't going to end up changing.
Yeah.
Does that make sense? Yeah.
The recursive tree.
Yes, of course, that's the recursive tree.
It was,
You wanna go?
Yeah, recall back, I see it num2 equal null.
Mhm.
1, but why is 1? Why is 1? First one is negative.
Because that's what the problem said to do. If num2 is bigger, return a positive number. So we just chose to do 1. That's okay, no worries. You just following what the problem says. Don't always forget what the problem says. So, any questions on this? Yeah.
Which one's null first?
This, yes. These two, no. You can flip those two. I don't see why you couldn't flip those two. But this, you have to check first if either of those are true, if this one's true. Does that make sense? So, any other questions on this? Does this make sense at all? I hope. I know this one's a little trippy. So that was everything for linked list. There it is again. Oh yeah, the base case can be done a few ways, of course. Any other questions? All right.
What are the other 2 points? That was 8 points total?
No, that's should be 10. Isn't it 10? Yeah, it's 10.
2 points indicated.
3.
Base case, okay.
Oh, for yeah, so 3, 6, 7, 8, 9, 10.
Yeah, we're over.
All right, so last up is queues. Can we only end in 10 minutes? Can we end in 10 minutes?
Speed on.
Okay.
6:15, no?
Yeah.
Oh, it's 6:15. Okay.
That's what you had, right?
Yeah.
But yeah, no problem. So already assuming that what you guys know about queues, so we're just gonna go through this very fast. Queues, first thing, it's basically like a linked list, but you guys know FIFO, first in, first out, and then stacks is somewhat of the opposite, last in, first out. So whenever you think of a queue, you think of like a standing line. you know, whenever you're going to get tickets in the movie theater, you have to come through in the back, which is the on queue, which has a old one lookup, and then you have to exit at the front, which is a DQ, which is the old one lookup as well. But when you're traversing the queue, it's a actually skip to the next slide. Yeah. So when you're inserting right here, this is the old one lookup, the fastest runtime. And when you're exiting, it's the old one lookup as well, which is also the fastest runtime. But when you're traversing through the queue, so when these nodes are moving up, then it's the old end lookup time. So next one. So in code, you can basically see how it's structured when you create a onQ and a DQ function. So right here, basically we grab the back pointer and then we created it out of a new node. And then within this if statement, we're basically setting the front pointer to the rear and to the temp. And then for the DQ, we basically do somewhat of the opposite. So where we grab the back pointer and then we store the head into the temp variable, and then we set the head to the head next. Anyone have any questions about that? Yeah, pretty simple concept. And
Who hates circular keys after yesterday's quiz in Ahmed?
Yeah, bro, that one time question was chopped.
Oh, yeah.
Anyway,
yeah, you want to explain something?
not really.
Yeah, to be honest, I don't know how to really explain this slide. It's a very basic queue, but you guys know what queues are.
It's a circular queue, basically. It just uses the array over and over again using modulus, basically.
And then, yeah.
You want to do this question?
Um.
Come on, you should give it a swing.
Actually, so.
Here, use this so you can like actually write it out.
Okay. You gotta like go to class like right now.
Wait, what?
I gotta go to class.
Oh, shoot.
Yeah. So sorry about that. I
There.
really wish.
All right.
Sorry about that, guys. I gotta go to linear circuits. You guys know what that is. So wish me luck.
All right, give me 30 seconds, y'all.
I would say that like stacks and queues are my favorite data structures. Right in front of BSTs. BSTs, I have fun with BSTs. So yeah, stacks and queues.
Binary search trees are fun.
Yeah. Like DMA, like in all honest opinion, you guys are not gonna need the after C.
DMA?
Yeah, he's right. All the other languages do it for you.
Python, automatic garbage collector.
Yeah, Java.
Java as well.
All right, so let's do this question. Then we can all go home and take a nap or whatever. Keep studying.
I'll take care, man.
You too. Are you guys ready? Everyone ready? All right, cues. We are going to simulate a simple battle involving players in a queue. The battle game has the following rules. The game involves several battles. Each battle will involve the two front players in the queue. The winner of the battle is determined by figuring out who has more HP. In the case that both have the same HP, the second player in line wins. The loser of the game is just basically killed from the queue, and the winner's added back to the queue. The game is over when there's one player remaining in the queue. Does that make sense with the rules? Basically, each battle, you take out the two front players in the queue, see which one has the highest HP. Whoever has more HP gets back into the queue at the back, and the person with the less HP just dies. And then you keep doing this over and over again until there's one player left in the queue. Does that make sense? So if you think about it, this is technically just getting the person in the queue with the highest queue, if you think about it. Yeah. Well, that's why we're doing it. Complete the following function battle game that simulates this game. You provided the following structure definition and helper functions that have been implemented already. You must utilize them reasonably for full credit. The function should also print the name of the player that won the game. It is guaranteed that the queue pointed to by game queue has at least one player in it. All right, so let's look at the structure. We have a queue of two players where they have the front of the queue and the back of the queue basically, and then the size of the queue. Then each player has a name, an HP, and then appointed to the next player in the queue, basically. Does that make sense? This is almost like a linked list structure, but then this is the actual queue. So then we're also given a bunch of auxiliary functions we can use, which is nice. So really, we just have to just implement these rules. That's all it is. So we have to do this a bunch of times, right? So if you have to do something more than once, what do you need? A loop. Would I want to do a for loop or a while loop here? Why? Right, we don't know how many times we're going to be doing this, so you want to use a while loop. So we can say while. Now, how would I check if there's more than one player in the queue?
Size. Runs is not equal by.
You can do that, but let's use the auxiliary functions here.
Can we just use the pointer that points to the next player from the player start?
We're trying to figure out the size of the queue. We want to know how many, we want to basically see, we keep doing this till there's only one player left in the queue. Say that again? Not size. You have to be careful. You can't just say size. You can just call this size function. All these functions are available to you to use. So you could say, yeah, size with game queue. Well, that's greater than 1. Basically, keep doing this until there's only one player left in the queue. Does that make sense? Okay, so then we basically just did this. Now let's see. Each battle will involve removing the 2 front players in the queue. So basically, we're removing 2 players from the queue. So if I'm going to remove something from the queue, what function here can I call? DQ, exactly. And what does that return? A player T pointer. So we basically need to have 2 player Ts, player T pointers. I'll call this one P1. And that's going to be equal to DQ of the game queue.
Doesn't every sentence say long?
Shouldn't matter. And then same thing again for this time, just with the second player. I should have probably just copied it, but whatever. Does that make sense? Basically, we're just getting the 2 players out of the queue.
Yeah.
Any questions with that? Okay. Now, we basically now have to see the winner of the battle is determined by who has the most HP. Well, if there's a tie, the second player would be the winner. So let's just assume for simplicity, if player 2 has more HP, they're always back in the queue. Or if they're the same, player 2 is back in the queue. So we can just easily, just to make sure that always works, just assume, let's take care of player 1 first, see if they have more HP. Because otherwise, if player 1 doesn't have more HP than P2, then you know P2 is going to win no matter what. So we can do this by saying if P1 arrow HP is greater than P2 arrow HP. I'm just doing this based off the structure definition. Then, well, what do? You NQ the winner. So you would NQ based on this function up here, game queue, and then P1, and then we'd kill P2. So then how would I kill P2? Delete player. Well, and then if they're the same or P2 has more HP, well, then you could just do an else and say, all right, well, do the same thing, except just flip the order or flip the player order. So this becomes P2 and that becomes P1. Does that make sense? And then that's everything in the loop because we've done this a bunch of times. If they have the same HP, player 2 will win. I don't know why, but that's just what it is. So that the way we've written this, no matter what, if they're the same or if player 2 has more HP, player 2 will win. Does that make sense? Any other questions? Now, are we done? Why? We have to print who wins. So we can just do that by saying printf, oops. %s wins. And then we can, how do we access the player who wins? It's the person at the front of the queue. So you can do that by saying, well, let me put a new line in quotes. That would be good too. We can do that by saying front of game queue arrow name. And that's it. Does that make sense? Where's what come from? That's this function, because we want the player at the front of the queue. That's the winner at the end. The game keeps going until there's one player in the queue. So I'm sorry? Yeah, the provided function front. So basically you keep doing that until there's one player in the queue, then you just get who's in the front, basically.
Access the name, just try getting, just calling the function.
No, yeah, you can do that, because that's returning a value. Front game queue is a player, so you can dereference that. Does that make sense? Nina? Yeah.
Oh, yeah, that's fine.
To move what? Well, no, it's only, you only do 2 players at a time. We're calling, there's a function that'll do that for you. We're calling this DQ function that does it for you. All these functions are, you can utilize all those functions, and you should, saves you time. Any other questions? So there it is, again. I don't think this one's too bad, honestly. So that's it. So I hope you all found this helpful. Sorry if I was a little shaky. Had a long week. Thank you. Good luck studying for your midterm. Come to office hours and whatnot. Get help. We're here for you. Give me one second.